Hey guys, so welcome back to your next class of Catalyst concepts. Today we look at one more topic that was remaining. That's another type of eye defect, and we'll also look at what do we mean by the power of a lens. Okay, so first let's get to the next eye defect. All right, so this defect is called presbyopia. Okay, now what is this presbyopia? Presbyopia is, in a way, we can say it's like a combination of both myopia and hypermetropia. In the sense, when people gradually cannot see either nearby or far. Okay, it sounds odd, but basically, this is what happens with age. Right, so when people get older, you see a lot of old people wear glasses because they cannot see clearly. So the reasoning behind this is simply either the ciliary muscles get weak, so they are not really able to flex hard enough to adjust the focal length of the eye lens, or it can also be if the lens becomes harder. It's not as soft as it's supposed to be, so you cannot really stretch it even if your ciliary muscles are strong enough. So basically it just becomes a little more rigid, right? In a way I can call it rigid. So presbyopia is generally age related only, and since it has both of our previous defects, both myopia and hypermetropia, even fixing it would need both of those approaches, right? We are going to need to use both the types of lenses that are used for either of them. Okay, so if you see some of these old glasses, how they look, it's like they are made up of different, right? At the bottom they are a bit different, and at the top they are a bit different, right? So for patients with presbyopia, there is a special type of lens. Okay, we call them as bifocal lenses. Okay, bifocal, it's in the name, right? Bifocal, there's two types of different focus, right? Basically it means two different types of lenses. Okay, so bifocal lens is nothing but combination of convex and concave lenses. Okay, it's kind of not exactly half and half, but both of the lenses are going to be there present in a single lens. That is a bifocal lens. Okay, so generally if you have a lens that's about looks like this, the bottom part is going to be a convex lens, and the top part is going to be a concave lens. Okay, simple reason being, the concave lens helps in seeing far. Okay, it'll allow you to see far. So when you're looking straight, you look at to the top of the glass, right? So you'll be able to see far. So that's why the top is a concave lens. But when you're reading something, you kind of tend to look down. So the convex lenses help in magnifying what you're reading, basically, right? So that is why a bifocal lens is built like this. Okay, the top part is concave and the bottom part is going to be convex. Okay, so this is all about presbyopia and the type of lens that's used to fix it. All right, now let's come back to the topic of what do we mean by power of lens, right? So generally if you talk to someone, they say what is the power, sight, how much is your sight, what is the power of your glasses, there's more power in this, less power. So generally when we talk about glasses and power, what is this power that we're talking about, right? So if I have to talk about power in lenses, it is basically about how strong the lens is in terms of bending the light. Okay, we know there are two types of lenses, both converging and diverging. Okay, so I can simply say power of lens is nothing but degree of convergence or divergence of light. Okay, if it diverges light a lot, it's a very strong concave lens. If it does it less, its power is not that high. Something like that. Okay, you say convergence or divergence because convergence counts for convex lenses and divergence for our concave lenses. Okay, so that is the power of a lens. Now, since we have a definition for it, we'll also have a way to calculate it. Okay, now how do we calculate this? So power of lens is simply a reciprocal of its focus. Okay, power of lens, we generally call it P, equals to 1 by F. Okay, over here, F is in meters. Okay, if F is in meters, then yeah, you can take it as 1 by F. Or we can also write 100 by F if F is in centimeters. Okay, since 100 centimeters is 1 meter, so this one will become 100. So if you have the focal length in terms of centimeters, you can use this. Or if you want to find focal length as centimeters, you'll use this formula, or else you can use this formula. Very simple stuff. P is nothing but power of lens. F is the focal length of that lens. Okay. I can demonstrate this with a very simple sum for you. Okay. I'm going to put it like this. Okay. A doctor prescribes a lens of 4D power to Rohit. What is its focal length? Okay. Now, you must be asking, what is this D over here? Okay, 4D power. So the unit of power for lens is nothing but diopter. Okay, just like we have length is centimeters, for power, the unit is diopter. Okay. All right. Simple question. Let's try to solve it. Now, we know the power, 4 diopters. We need to find focal length. So if I have to do that, I'll simply do P equals to, I can do 1 by F or 100 by F. I'll do 100 by F. Okay. 100 divided by F. Now I can cross multiply. I can write this as F equals to 100 divided by P. Okay, since we don't know what is F, we need to find focal length. So I did it like this. Simple. Now, F equals to 100 divided by, what is the power? It's 4. Which is nothing but 100 divided by 4 is 25. Right? And since I did 100 by F, it means I'm going to get my answer in centimeters. So that is 25 centimeters. Simple. So the focal length of my lens will be 25 centimeters. That's it. Okay, very simple numerical. There's just one simple formula. Either you'll have P or you'll have F, and you'll have to find the other one. Okay, so this is it for you. This is the last topic for this chapter. So if you have any doubts, any questions, you can put them in the comment section below. All right, so the remaining part is not yet going to be part of it, like the activity section. So we are going to jump straight to our final quiz next, and after that we are going to go to the next chapter. All right, okay then, thank you so much, and I'm going to see you in the next class.